Okay, good morning. Welcome to
FunMath186.
FunMath number 186. Okay, so we had another real challenge problem on an old AMC8 today, right?
Yeah.
And this was 1991 problem number 17. So here's a problem based on that, okay?
Mm-hmm.
You have a row of 57 chairs. What is the maximum number of people that can sit in this row if no one is allowed to sit next to someone else? Okay? Do you understand the problem?
Yes.
Okay. How would you approach a problem like this?
Well, 60 chairs is easier because then 30 people can sit in it. That's the maximum number of people that can sit in it.
Okay.
Because
Why do you know that?
Because 60, every other person is the maximum number you can have in a row if nobody's allowed to sit next to somebody else. And every other person for 60 is 30.
Okay.
Then we could try going back 59, 58, 57.
I'm curious why. I'm asking you to solve for 57.
Yeah.
And now you're trying to solve for 59.
Well,
Have you made your life easier or
no,
harder?
A little bit harder.
Okay. So I've given you one problem and you said, oh, this reminds me of a harder problem that I don't know how to solve.
Well,
So let's find a better approach. Okay? Let's find a better approach.
We can find a pattern. We can start just one chair.
Is finding, if the row only had one chair, would that be easier?
Yes.
Okay. Go ahead.
So if the row had one chair, then one person would be able to sit in it.
All right.
If the row had two chairs, one person would be able to sit in the row. If the row had three, there would be two people in the row.
Why is that?
Because three people, three chairs, every other chair.
Interesting. Okay.
And row 4 would also have two, because if you added another one in. So 4 would have 2. Seems like we're going 1, 1, 2, 2. Let's see, 5. We get 3. Seems like we're going 1, 1, 2, 2, 3, 3, and so on.
Okay. So what's it going to be for 57 then?
Well, 10's going to be a 5.
10 will have 5, yeah.
But how are we supposed to figure out 57 from just this?
Yeah. That's why this is a good challenge problem.
We could just write it all out. But
We could.
That might take a lot of time.
Yeah, that would take a lot of time. But we have enough in this pattern here to figure out the answer. 6 would be how many?
6 would be a 3.
6 would be a 3. Okay, so 57.
Well, I see the last one in each of these segments, 1, 1, 2, 2, 3, 3, is this number times 2. So.
Okay, good. How's that going to help us?
Well, that would mean for 60, it would be that's the last one in its.
60 would have 30. Okay. So now, let's go back to your problem then. How many would 59 have?
Well, according to this, 59 would also have 30.
According to this, 59 would have 30. How many would 58 have?
58 would have 29. And 57 would also have 29.
29. Okay. So when does the pattern change? When the number of chairs... What can you tell me about the number of chairs when the pattern changes?
When the pattern shifts, the number of chairs is double the number of people.
Okay, so at an even number of chairs, when you go from even up to the next odd one, it goes up 1. Okay? So 57 is an odd number, so we could say for 56 we were just dividing by 2, which was 28, and when we go up to 57, we got 29. Or you said 60 is easy to divide by 2, but now we're going down the pattern this way. So 59 has the same as 60, but 58 has 1 fewer. Okay? All right. Good job. That was a tough problem. Tough problem.